Good day, everyone. My name is Yulia Chekuneava, and I'm Director of the Clean Growth Leadership Network. I'm delighted to be joined here today by Maurits Dolmans, who is CGLN Fellow and Partner at the international law firm Cleary Gottlieb and Hamilton. Maurits, I think we started to debate with you on different energy sources and the role of nuclear, more specifically, a year or so ago. So I find it particularly exciting that ahead of the World Nuclear Symposium, we are partnering with your firm to host a one-day conference looking into the specifics of nuclear technologies and the role they can play in solving the climate crisis. So to start our conversation, I think it would be helpful if you can elaborate why it is timely for this discussion in an open forum and essentially why we're putting this event.
Thank you, Yulia. The world is looking for new technologies to create energy for a rapidly growing population while keeping climate change under control. And indeed, we should reverse the damage done to climate change. And we want to explore whether new nuclear technology can help. The world is battling effectively with four concerns. First, the world should become climate neutral in 2050 and reduce greenhouse gas emissions by 55% in 2030. That's 8 years from now. At the same time, emerging economies need cheap energy to develop. More than 1 billion people have no access to reliable electricity. And even those who have access are going to need more energy for their economic development. So we should expect world energy to grow 25% in the next 25 years. And right now, it looks like 70% of that will be coal, oil, and gas. So emissions are increasing when we need them to shrink. Now, the health costs from particulate emissions and the social and capital costs from climate change will be enormous. Third, we need energy security. If we learn anything from the war in Ukraine, it's that we can't continue to be strategically dependent on supplies from unstable regions or unreliable sources. And fourth, of course, we should ensure safety and minimize or get rid of nuclear waste. So clearly, renewable energy are going to be a core component of this strategy. But solar, wind, and geothermal energy and tidal and hydro are not going to be available in all geographic areas. And solar and wind are intermittent. That means that they cannot meet all of the world's needs for fuel, electricity, and industrial heat all the time. As they like to say, the sun doesn't always shine and the wind doesn't always blow. So we need a carbon neutral, safe energy source that can provide a baseload electricity when renewables are not available and that can carry peak loads when demand is at its highest. And we need this energy at competitive prices, that is to say less than 45 cents per kilowatt hour for electricity to be competitive with natural gas. And it has to be less than 7 cents to be competitive with new coal power plants. If we indeed included the true price of hydrocarbons, now at least 12 cents per kilowatt hour, if we included health and climate cost, then renewables with battery backup and nuclear power are already competitive. But the true cost of coal, oil, and gas are not included in their price. Most countries do not have an emission pricing system for electricity. So we need new energy below 7 cents per kilowatt hour at least to cut out coal. And we need industrial heat for hard to keep decarbonized sectors. Now, new nuclear technology may offer this, and that's what we want to explore during the conference.
Thank you for this introduction, Maurits. I think it's touching all of the important points. But before we get into specifics of the conference, I think it would be helpful if we also set the scene and give a little bit of a background. So let me introduce CGLN first, and then if you could introduce Cleary in your passion for the new energy solutions. So the CGLN is an independent, private and not-for-profit organization. I call it a social enterprise, which is more sort of a scientific term for that. We harness the power of networks, and we are curating a platform for academic and scientific innovators to connect with business leaders, financiers, and policymakers to generate solutions to tackle the climate crisis and essentially build welfare and prosperous world for all. What differentiates CGLN from others in the space of climate change? First of all, we are a platform and we give access to people. And secondly, we fundamentally believe we need to stop living in silos. We need to collaborate across sectors, and energy is a vital line across all of the sectors. And also we need to collaborate across generations. And those two beliefs drive and inform everything we do as a network. And if now you could introduce a little bit Cleary and yourself.
Well, thank you, Yulia. So CGLN, the Clean Growth Leadership Network, is a pro bono client of the firm, and we are very proud to work with you on this conference. We hope it will be of interest to clients and non-clients alike. As far as I'm concerned, personally, since 1985, my work is focused on antitrust law and innovation, especially in the IT area and also in energy. In the last 5 years or so, sustainability really came to the foreground. To deal with the challenge of climate change, biodiversity loss and energy security, Cleary Gottlieb advised on a number of tools on 4 continents: regulation, taxation, litigation, cooperation between firms, and innovation. And for regulation, carbon taxation, and litigation, we have a vibrant sustainability practice group in Europe and in the US, and increasingly elsewhere too. Great colleagues. For cooperation between market players, I've been advocating the integration of sustainability economics into antitrust policy. And antitrust authorities in the EU are beginning to agree, although there is still a way to go, especially in the US. The greatest result, however, I think, will come from innovation. There are some fantastic technologies being developed to deal with the climate crisis. And many of these you can find in a website called Project Drawdown, really worth a look. And we need this innovation, especially in the energy sector, because energy is a foundation for all economic growth. And the war in Ukraine shows that without energy security, we won't get a transition to a carbon-free economy.
Yeah, I couldn't agree more with you, Maurits, regarding the role of energy and the energy security in the way we are going to be transitioning to the low carbon economy. I think, you know, as a next question, I want to discuss with you what, in your opinion, the conference can achieve. What are the key outcomes or learnings that you would like to be explored?
Well, new nuclear technology is in development again after quite a bit of stagnation in 3 areas. First, small modular reactors. Second, 4th generation technology like molten salt reactors, and then fusion. And we need to speed up that development to deal with the climate crisis. And for that to happen, and for these technologies to become commercially viable, they need a combination of things: public and private finance, up-to-date regulation, cooperation between industry players, including users, industrial users who would sign up to offtake agreements to underpin investments, and political support and public information about how this can address climate change and ensure a stable energy supply. We did this to get to the moon. And so we can do another moonshot project, creating synergies and momentum between public and private to get to zero carbon. And this is beginning to happen for small modular reactors, and with a much longer timeline for nuclear fusion. Even today, Google and Chevron invested in nuclear fusion startup TAE Technologies, and that already raised $1.2 billion. And we need the same for 4th generation nuclear technology.
Yeah, Maurits, I mean, as I said in the introduction about CGLN, we fundamentally believe that without cooperation and you know, collaboration across multiple parties, it's impossible to achieve a faster outcome. So what sort of synergies we need, and what sort of cooperation maybe more specifically would be relevant for nuclear?
Thanks, Yulia. Indeed, we need synergies and cooperation. And right now, there's an impression that most of the players are doing their own thing, missing opportunities. So we propose to bring back together various stakeholders for all of the 3 technologies. And there's a whole list. So private finance, because they may want to explore investment opportunity. Nuclear technology owners, because they might want to cooperate and coordinate R&D, and perhaps combine assets to create synergies within the limits of antitrust. And carbon-intensive industrial companies like steel and aluminum, cement, fertilizer, water desalination, electricity generators, they may want to co-invest and signal offtake commitments to underwrite investments by these technology owners and by power generators. They also may want to prepare to meet net zero commitments, and this may be a way to do it. Now, oil and gas companies want to remain relevant in the long run, and that means they have to transition to net zero. And managers of nuclear waste and decommissioned facilities, they want to develop ways to use waste as fuel in molten salt reactors and reuse decommissioned sites. And governments will want to build a competitive economy to meet the Paris Agreement goals and encourage employment in new tech. There's a lot of fantastic employment to be had here. Now, regulators should update regulation to address the specifics of new nuclear technology. Academic institutions want to invest in fundamental research and educate a new generation of engineers. And NGOs like CGLN will want to inform the public, monitor and check that everything is done in a way that's consistent with public interest and safety and so forth, and want to provide a public forum to discuss. So there's a lot of people that should come together to make this moonshot work.
Yeah, and a lot of people from different industries. However, what we have noticed, and maybe a skeptic in our audience would ask you, why nuclear? Isn't it we already had a couple of solutions to this in hydrogen or mass electrification and energy storage, a distributed energy system? So why nuclear now?
Well, these are part of the solution for sure. And the EU in July, just last month, approved a 5.4 billion euro hydrogen project. But hydrogen, you have to keep in mind, is just a way to store and transport energy. And they have to solve two problems for that to be useful. First, almost all the hydrogen currently produced is gray or blue. That means we are making it from methane or natural gas through a process called steam reformation. And that's not only inefficient, but also leads to very high CO2 emissions. And if that's all we do, it would be terrible. We might as well burn the gas and the coal directly. Now, in the case of blue hydrogen, we would be capturing the carbon when making hydrogen and storing it underground. And that's still quite expensive, doesn't capture the so-called fugitive emissions, and some of these storage technologies may leak. So hydrogen can be made without CO2 emissions by electrolysis using electricity or thermal dissociation of water. I could go and bore you longer about this if you wish, but I won't. But the electricity or the heat that is used for this process has to be made CO2 free if it is to be green. Otherwise, you're just using dirty energy to create clean. That's not very efficient. And the second problem with hydrogen is that it can be quite inefficient. You lose 2/3 of the energy if you convert electricity to hydrogen or ammonia for storage and transport, and then reconvert that back to electricity for local use. So, and similar comments can be made for electrification. It's necessary, but not enough. It's great to have to electrify energy supply and to have everyone drive electric cars and use electricity for heating. But if we produce that electricity with hydrocarbons, we're just fooling ourselves. We'd be still spewing out those greenhouse gases. So we need to ensure that electricity is generated cleanly without greenhouse gas emissions. And that electricity supply is to match demand, which fluctuates daily and seasonally. So we think that new nuclear technology may be part of that solution, provided, of course, that it can be done safely and efficiently at reasonable cost and without the risk of nuclear weapons proliferation. And that's what we want to discuss at the conference.
But coming back to another angle, cannot we just focus on renewables combined with the energy storage?
And that's, I agree, Yulia, that's definitely something that is being explored. And there's some very exciting technologies being developed, for instance, concentrated solar panels with molten salt storage. So arrays of mirrors that concentrate the solar light into one point, which becomes incredibly heat and melts salt. And that's used almost like a battery. And a lot of that technology is useful also for molten salt power generation, fourth generation nuclear. Now, the EU is supporting a new battery technology as a project of important EU interest. Great. Now, the need of rare minerals may get in the way, and there may be clever solutions. I read recently something about sand batteries in Finland, but we can't rely on that until we know it works everywhere all the time. So that's why we want to explore whether nuclear and renewables can be combined, complementary technologies to ensure energy security, to offer energy prosperity to these emerging economies, and to abate climate change. And it may also help with industrial heat, which is a category of its own.
Yeah, I mean, I'm fully aware as a practitioner of metals and mining industry in my past that industrial heat, the sources of industrial heat, is one of the major problems to decarbonize major industrial processes. But I think what would be helpful for the audience, if you can explain a little bit what is the industrial heat?
Well, a lot of industrial processes like metals and mining indeed do not just need electricity, but they need very high temperatures of hundreds of degrees of Celsius. And you can generate that with electricity, but that requires a lot of energy and emits a lot of greenhouse gases. Now think about processes that use like industrial heat, like production of green hydrogen and the electrolysis I talked about, production of green ammonia, which is a way to store hydrogen safely, or a fuel for carbon-free transport and an input to fertilizer, green steel, aluminum, cement, fertilizer, water desalination. There are a lot of other hard to decarbonize products. And we even want to think about carbon capture from the atmosphere for geological storage of that carbon or production of synthetic fuels, for instance, to use in airplanes, which then would become carbon neutral if this carbon capture is done itself in a carbon neutral way. Now, nuclear technology generates enormous heat, and that can be used for two reasons. One, to drive steam turbines to generate electricity, but also for this industrial production, if the plants are small enough and close enough to the nuclear reactors.
You mentioned a few interesting points there about the different, different applications of the industrial heat or different processes. I think the buzzword currently is green, and lots of news flow is going on about how steel can become specifically green. Yep. So I think it would be helpful if you also give our audience a little bit of detail on what is green steel.
Well, actually, green steel is a great example of where new nuclear might be able to help to eliminate carbon, and a number of steel companies like ArcelorMittal are working on this. Now, steel production is responsible for a lot of greenhouse gas emissions. But you can use hydrogen to make it carbon neutral, of course, if the hydrogen is green, right? So green hydrogen can be used to reduce iron ore. That's to say, to take the oxygen out of the raw material, which is necessary to make steel. Today, this is usually done with coke, which is a type of coal, or with natural gas, and that emits a lot of emissions of greenhouse gas emissions. Now, green hydrogen can also be used to make green ammonia, which can be used as a fuel for ore and steel shipping. Now, combine this with new nuclear to make the green hydrogen, supply the heat for smelting, and with carbon-free lime, for which technology is becoming available as well. And you have green steel. And this goes to show how foundational energy is and how conversion to carbon neutral energy can help decarbonize whole industry sectors. There's a lot of work to be done still, but the fundamentals are there, and it's very exciting.
And then the other part that you mentioned that I think is a top of mind for many people is actually carbon capture. And I think in certain industries, there is a little bit of progress on how to capture the carbon in the air, but it would be interesting to learn more from you how nuclear can help with that.
Well, we need to capture carbon from the atmosphere and put it back where it came from, basically, not just zero carbon economies, but negative carbon. And there are two reasons for this. First, we won't be able to switch to carbon-free energy and carbon-free industries overnight. The world is going to be burning coal, oil, and gas for decades to come. That carbon is still being released in the atmosphere. And as I explained at the beginning, it means that we are going to increase emissions if we don't solve it. We can't afford that if we want to meet the Paris Agreement goals. Now, some of that carbon can be captured at the source, but a lot of it is not or cannot be fully captured. So we have to filter it out of the atmosphere. The second is a really much more difficult problem, which is that we have warmed up the atmosphere so much that ever fiercer wildfires occur everywhere, even in the Arctic and in the middle of London, as we saw yesterday, several of them. And permafrost in the tundra is melting. This releases huge amount of greenhouse gases, CO2 and methane, and that does not respond to regulation or to taxation or to education. It just happens because of the heating that has already occurred. And methane is a very strong greenhouse gas, much stronger than CO2, and over time turns into CO2, so it remains available for a long time. So this creates an awful negative cycle. More greenhouse gas retains more heat in the atmosphere. That leads to the release of more greenhouse gases, and we can't control those emissions. And the only thing we can do is to capture them from the atmosphere and put them back where they came from. Now, carbon capture and storage takes a lot of energy. And there's a plant, a very interesting plant in Iceland using the geothermal heat. But that's Iceland, you have that kind of heat there. That type of energy source is not available everywhere. And that's where new nuclear technology may be helpful, we hope, or think, we hope.
Another skeptic in the audience may ask you, that's all very fine, but it's very capital intensive. We need to make a technological breakthrough. Why don't we just reforest the world?
Well, reforestation is really important, also to restore ecosystem and soil regeneration. Very, very important. There's a lovely organizations called I Give Trees that does this. And there are many others who are active in this area. So long as it's done responsibly, using local varieties and not lots of needle trees, and take into account soil restorations and the needs of local communities. So it's not that easy to do it well. But it appears that we're not going to be able to plant enough trees to capture all the CO2 we emit. We should try to, but it may not be possible. And we cannot capture that CO2 long enough because trees die, right? Wildfires return the CO2 into the atmosphere. One of the projects that I'm involved in for tree planting had a wildfire last year. All that tree, that carbon that was absorbed was re-emitted. So reforestation is necessary, but it's not enough. We need to switch to a carbon-free energy. And again, that's where new nuclear may help.
And any specific nuclear technologies do you have in mind?
Well, we are hoping to discuss 3 new technologies. One is small modular reactors. They are like small, literally small nuclear reactors in the form of building blocks of up to 300 megawatt of power, much smaller than the huge plants that are currently being built. Well, not so many are being built, but that currently are being used. And these benefits from existing technology, but in much smaller form factor. They can be built centrally in one place, like Lego blocks in a standardized fashion with passive safety. And then like Lego blocks are placed in arrays to which modules can then be added as needed if more energy is needed in that particular location. Now, the second is 4th generation nuclear technology, including molten salt reactors. And one of the advantages is that these can actually burn nuclear waste from the current nuclear plants, or they can also burn non-radioactive elements like thorium. Now, they have a lot of advantages and some of that has already been shown, like they can't melt down. So the risk of Fukushima or 3 Mile Island or Chernobyl is not going to happen with these molten salt reactors. And current generation nuclear reactors use light water at 150 atmosphere for cooling, but molten salt reactors have no high pressure system that can explode. They work at 1 atmosphere pressure, so they don't explode. And they offer passive safety. If humans walk away, they shut down by themselves. And crucially, this is really a very interesting advantage, is they have no long-lasting waste. And they can even burn the waste of that the current technology has created to near nothing. And there are little to no nuclear proliferation concerns, we think, but that's some of the things we need to discuss at the conference. Now, and if you want to use thorium as a fuel, the advantage is that it is not rare. You can find it everywhere, and it doesn't need to be enriched like uranium. So we don't need to worry about strategic dependencies on unreliable or conflict sources. And finally, these are scalable, like small modular reactors. And third, the most long-term, is that we want to discuss fusion. This is energy produced when different forms of hydrogen like deuterium and tritium are slammed together. like in the sun. And it's said that fusion is always 15 to 20 years ahead and will be for quite a bit of time. Now, we have seen quite a number of breakthroughs recently. There are still challenges like materials impurity, unavailability of components like superwires, getting a workforce, producing tritium, which doesn't occur in nature, and the absence of a marketplace for fusion. But new fusion companies are entering the market, and there have been really exciting developments. Now, I could go on because this is really exciting technical stuff. I love this innovation and its potential for secure, safe, and affordable and carbon-free energy. There's a great website if you want to know more. It's called practicallycarbonfree.org. I would recommend, have a look. Go through it for the layperson. It's quite a useful resource.
Yeah, Maurits, the technologies you have described, I think they fall into the path of the actual, timeline for the transition to net zero. However, I want us to get back a little bit to the recent past. And of course, you already mentioned that European Parliament, made the decision to include nuclear in their list of sustainable investments. What do you think are or will be the implications of this decision?
Yeah, well, this gets a little bit legal. Sorry for that. These are called the so-called taxonomy rules, that basically what is green and what is not green. And these rules determine whether a certain economic activities can be treated and marketed to the public as environmentally sustainable. So if they comply with the conditions of the taxonomy, then these investment in these activities or the financial products related to these activities can be marketed as green. Now that helps consumers or investors, private consumer investors who want to focus on sustainable investment, because they may want to decide, I want to only invest in sustainability or in impact. So I don't want to have non-green investments. This label allows them to decide what's green and what's not. And it also helps green firms because they may get cheaper finance. And these rules are also going to be used for other purposes like state aid, for instance. Now, I have my doubts about some of the taxonomy, I have to admit personally, like for instance, bioenergy. Is that really sustainable? Wood harvesting can create real havoc to biodiversity and to ecosystems. Personally, I also have my doubts about natural gas. Does it meet the so-called do no significant harm principle, which is part of the taxonomy rules, and which says you must ensure the absence of significant damaging side effects? Now, the significant damaging side effect of gas is carbon emissions, but on the other hand, it allows a transition from coal. So there's a little bit of a silver lining. In the end, it was a political compromise. Germany needs investment in natural gas as a transition and doesn't like nuclear. It's a pity, but that's the reality. And France wants to support nuclear and didn't like natural gas for climate reasons. So sometimes compromises are needed as the art of the possible. And we should also keep in mind that not all gas or nuclear is going to be qualified as green. There are limiting principles. So for instance, it always has to be the, quote, best available technology. And there has to be accident tolerant fuel. And there must be ways to dispose of radioactive waste, for instance, burning it in molten salt reactors. So there are limiting principles, and on balance, I think it's better than nothing. But a lot of debate went into this.
Yeah, I can imagine. I think it's the legislation that went into several circles before it was adopted by the European Union. I think, like, to close off the conversation, or to wrap it up a little bit, in your opinion, for nuclear technology to play a key role in tackling the climate crisis, what changes need and can happen between now and COP27 and maybe even beyond?
COP27 is very close, right? I think what we need is an end to the war in Ukraine, but for our conference, what we need is a moonshot moment, and the public and the private sector and suppliers, finance, and potential customers getting together to speed up R&D, to underwrite R&D and to bring these technologies to market. That's not going to happen before COP27. I hope it may be getting another impetus at COP27. So I'm really encouraging. I would love to see that that happen, and it has to be done soon enough to help achieve the Paris Agreement goals. And I hope this conference helps, and I very much look forward to discussing it.
Oh, thank you very much, Maurits. I think it has been an exciting conversation that we had, and a very informative conversation. Thank you for finding time to talk to me today. Our hybrid conference, just as a reminder, will take place on the 6th of September. Register your interest to attend today at CGLN webpage. Thank you very much for listening to us today.